How are you guys? Welcome back to my YouTube channel. Today we'll be dealing with a centrifugal clash. This is the Mechanotechnics N6. This is an introduction, right? We'll be looking at centrifugal clashes. We have what we call centrifugal clashes. We have three types. We have friction, plate, and then we have what we call conical clash, and I have centrifugal. I did friction, and then I have did we're done with conical. Today we'll be looking at centrifugal. And then also, guys, if you have not subscribed to my YouTube channel, I advise you all guys to subscribe to my YouTube channel so that you can be part of the family. By subscribing, you become a part of the family. Subscribe and click the notification bell so that you'll be notified whenever I post a new video. Alright, so we've given 1.5 there. You can see this as a centrifugal clash. We'll be learning about this. A centrifugal clash is mainly used in low more that you see this thing that we used to we use it there. Yeah, when most is used when to cut the grass, things like that. Yeah. All right, that is not a problem in mini bike as well as chain. So its working principle is meant to keep the engine running during the styling and disengage load during the starting and idling rear. So as shown in the figure 1.7, centrifugal clash has a driven member with a number of shoes. Yeah, that is here is something that might confuse you. There's something that might confuse you, but don't be confused. There's a difference between the number of shoes. This one will have the number of shoes is still n. Remember, when you are dealing with the friction, this becomes a number of contact. But now this will become a number of what? This n will become the number of what? Of shoes. Of shoes. When you're dealing with centrifugal, we'll have the number of shoes, not the number of contact, right? So we must know that, guys. Must know that. Must know. So here it's our pitch for centrifugal clash. We have a driven shaft here. You can see here these are shoes. You have indicated there are the shoes. You have shoes. There the one this thing with red there. I have highlighted with red. That is a friction lining. We have the spring, as you can see. Driven shaft, drum, spiral. That is how you can even construct. You can know how to construct this, right? This is a centrifugal. You can screenshot it if you want. I can zoom it. You can screenshot this if you want a picture of this. I can zoom it here. This is a centrifugal clash, right? This is how centrifugal clash looks like. As you can see, we have the number of shoes, spring, driven shaft, or driving shaft, driven shaft, drum. As you can see, friction lining there, and the spider. So this is the centrifugal clash, guys, by the way. So yeah, you see we have the shoes there, the number of shoes here. You have 1, 2, 3, 4. So you'll understand this if we go more doing some typical example. But referring to 1.8 below, when the clutch is stationary, the shoes are held back by an initial spring. Okay, we'll discuss about this. And the force also has to be taken into account in calculation. These shoes are usually held with a small clearance between the shoes and the rim. during the rest or stationary position, during rotational or driving shaft of the centrifugal class. You see there is a clearance. This, they say usually, let me show this with a light. These shoes usually are held in a small clearance between the shoes like that, as you can see there. And the rim during the rest, during the resting position there. All right. Okay. Right. Then during the rotary of the driving shaft, the centrifugal forces increase such that they overcome the resisting spring during to reach engagement. Once engagement is reached, the shaft will speed up and cause a normal reaction between the two surfaces. Okay. At the engagement point, the centrifugal force is equal to the spring force at the engagement. Guys, at the engagement, must take a note there. At the engagement, what will happen there at the engagement? There, at the point of engagement, the centrifugal force is equal to spring force. There, as you can see, at the engagement, Fc is equal to spring force at what? At the engagement point. Then after engagement, the centrifugal force increases, but the spring force remain as it was during the engagement. So as you can see again here, we have that Fn, this is a normal force, is equal to, take note, normal force is equals to what? Fc, centrifugal force, minus spring what? Force, like this. That is the normal force there. As you can see there, during engagement position, you see, during engagement position, you see the spring, you see the clashes, the shoes move in that direction, the force is applied there on the drum, as you can see. All right. Then during disengage, or I made a mistake, so this is not engagement. During disengagement, what's wrong with me today? Actually, during disengagement, as you can see, there's a space here, there's a clearance. I want to see, you see, we have a clearance, we'll have some clearance. There's a clearance, let me highlight, you see, that is a clearance. There's a space here, we have something we call clearance, you see, during disengagement. But when we are during engagement, see, there is no clearance. You see, there is no longer a clearance there. There is no longer a clearance. There is no longer a clearance. You see here, we have clearance. Here we don't have a clearance during what? Engagement. During engagement, we don't have what? Clearance. See the clearance there. But if we are given a clearance, we must take the clearance into account. We will learn about this. Then we have operating principle of the centrifugal clash, calculation of the centrifugal clash. Here we have some summary. Before we look at some solve example, let us look at the formulas and symbol. We need to do calculation for centrifugal clashes. Note, the centrifugal clashes does not apply different types of theories. Applicable cone and plate clash. See, this one does not apply. We are no longer applying weight theory and uniform weight theory. Does not apply here. The theories, they do not apply. So here we have formula and symbol. Centrifugal forces. Here it's a centrifugal force formula there. Also is given by that. It's given that Fc, which is centrifugal force, it's mass multiplied by angular acceleration squared multiplied by radius or diameter of gravity, or radius of center of gravity. This is the radius of center of gravity, right? So again, can be Fc can be calculated by mass v squared velocity there. This one is not like is rare for us to use. This one is not likely to be used, but the one that will use the most is this one. The one that this one is the one that is used the most. You'll use this the most. This one is rarely to use it during this topic. You'll use it when you are dealing kinematics. What is this? Kinematics, yeah, when you're dealing with kinematics, yeah. There's a kinematics, yes, there's a kinematics in mechanotechnics. There's a kinematics, you'll see that when you're dealing with tangentials, tangential acceleration, all those things, this one will use it. This formula is applicable there. There's a kinematics there. Also, when you're dealing with things like balance, you will see we have topic like balance and kinematic. So nevertheless, so that is what we have there, guys. So centrifugal clutch is measured in calculated Newton, mass obvious in kg, radius of center in mass, angular acceleration we know is radius per second, meters per second, linear velocity of phi. We have the formula for centrifugal force. Then the spring force, we should call it Fs, is calculated by what is clearly here, spring tension multiplied by wear multiplied by the number of shoes. That is clear. That is how you calculate what Fs, the spring tension. Also is given, also can be calculated by what? By mass multiplied by operating speed multiplied by what? By angular. All this squared, all that squared multiplied by r. You see, also this can be calculated by Fs. There we have the mass into percentage operating operation speed there multiplied by angular velocity. Then you square all of this multiplied by r. It can be calculated by that again, right? So this is measured in Newton. It's a force. Radius, obvious, we know that. Then torque, we have a torque. You see the torque is equal to coefficient of friction multiplied by the normal force multiplied by r multiplied by n. Remember, this is a normal force, because remember I said normal force is equals to what? To Fc minus Fs. So they just replace this here. Anyway, we can just write it as it is. It's a coefficient of friction multiplied by Fs minus Fc minus Fs, like this. This is a normal force multiplied by r multiplied by n. So as you can see, r is the internal radius of the drum, n is the number of shoes, this is in meter, this is in Newton. Your centrifugal force, okay, forces are in Newton. This has no SI unit, this is a number of shoes, not number of contact, number of shoes. This is how we calculate the torque. Now the power, everyone knows the formula of the power. So far we've been dealing with this formula since from N4. So let's check some let's check some example here. Example 1.12, we're given here this, it says a centrifugal clash. All right, this is a centrifugal clash, is designed to transmit the power of what? 35 kilowatts there at the maximum operating speed. You've given operating speed of that. The clash starts engaged at 70% of operating speed. All right, 70% of operating speed. It's operate using 4 shoes. You have 4 shoes making friction coefficient of 0.35. All right, the inside diameter of the drum is 330 millimeter, and the radius of center of gravity is 135 meter from the center of driven shaft. Says calculate the mass of the shoes. The mass of the shoes, that they say we should calculate that. Okay, fine. I can grab some data for you firstly. So what do we have here? Our data. What do we have? We have, as you can see there, here is the power there, which is 35 kilowatts. We have this power. What else do we have? Again, and number of speeds, which is 900 revs per minute, as you can see. Then we have what we call here the operating, right? The operating speed, whereby it's what we have 70%. Our operating speed 70%. I can write operating speed here is what 70% operating speed. Let me just say we have 70% operating speed. All right, we have now that. What else? This use 4 shoes. The number of shoes is simply what 4. All right, making friction, we have coefficient of friction there, which is 0.35. Inside diameter, whereby that is 330 millimeter, but we are dealing, what will you use? You are using inside radius. You divide this by 2. All right, as you divide that by 2, there this will be 165 millimeter, right? So let me just do like that. Now we have that 165 millimeter. The radius of center then it is 135 millimeter. Radius of gravity, radius of center of gravity we have now. So let us calculate. How can we start? Obviously, we're given power, we've given what? We'll take advantage of everything that we have here. We're supposed to take advantage of what we know so far, right? So remember, the aim is to calculate the mass. The aim. So the steps that we'll take is not a difficult thing. What do we know? We know that centrifugal force is equals to what? Centrifugal force is equal to mass multiplied by angular acceleration squared multiplied by radius of gravity, like this. All right, isn't it? Then we have, okay, this is FC. Mass we don't know, it's the one that we're supposed to want to calculate. Remember, this is the mass of the shoes, isn't it? The mass must be mass of the shoes multiplied by angular. What is angular? You know acceleration, velocity, angular velocity. We know this from n4 is this, isn't it? That is it, 2 pi n. So this is simply what? 2 pi n, isn't it? So this is 2 pi n over 60 squared multiplied by r. So you understand? So the mass we don't know, 2 pi n. How, what is n? Is 900 and what? 900 here. We can just write here. Again, you can write multiply by 900 all over 60. Remember, we square all of these, multiply by r, which was 135. You divide by 1000. If you divide by 1000, this will be 0.35 minute. So multiply by 0.135. Right. So if we multiply this, guys, simply multiply this, obvious our FC will be in terms of mass, will be terms of M will be 1199,157. This is what it's a mass. The M represent mass, guys. This is mass, will be in terms of mass. We don't know the value of mass like this. It's Fs. It's a centrifugal force. Okay, again we know that Fs, again we can calculate the spring force. We know this is mass multiplied by, I said, the operating speed, operating percentage, or the operating percentage. We know operating percentage speed multiplied by this angular right accelerating, all these squared times r. We've discussed about this. So we don't know the mass yet. We don't know the mass. We multiply by the operating speed percentage. We have operating speed percentage, there's 70%. 70% is the same as divide by 100. This will be 0.7. So this is simply 0.7 multiplied by the speed there. The speed is the same as 2 pi n. All right, 2 pi n divided by 60, isn't it? Because 2 pi n divided by 60, that is w is the same as like that. Then this will be 2 pi, what is n is 900 divided by 60 all over this squared, multiply by this. We said this is 100 and it's 100 and is 0.135, right? Then we multiply this, will be in terms of the mass. As you multiply them, we'll have 587, comma, this value is something else, 587 again, right? In terms of what? Of the mass. This is a mass, guys, or let me do it like this. You may think this is a meter, but this is a mass. Or want me to write it with big M like this? No, this is a mass, guys. Mass, we don't know. M represent mass. So far, this is a mass. This is now, this will be in terms of mass. Also, this one is in terms of mass. That this is our Fs. Fc in terms of mass. In terms of mass, also this we don't know. Okay, fine. But now we know. We want this. So, but we have given the power. What can we take advantage of the power? You can find the torque. What is torque? Torque is equal to 60 multiplied by power divided by 2n, 2 pi n, like this. We taken this from this formula. Pi is equals to 2, power is equal to 2 pi n t divided by 60. Then we make the torque the subject, then the torque will be that, right? So if we can substitute, we have 60 multiplied by the power. What is the power? Is 300 or 35 kilowatts. Then 35 times 10 power of 3 divided by 2 pi, the number of screw or speed there is 900. So what is torque? Torque is 361 Newton meter, right? This is what we have, the torque. Okay, the torque here. Now for centrifugal force, you must know the formula to calculate the torque. We've discussed, we say this is coefficient of friction multiplied by Fs minus F, like this. You put the brackets, or this is simply just if you know this is coefficient of friction multiplied normal force multiplied by R multiplied by N. Fn is said the normal force is the same as what? As F centrifugal force minus spring force. So here we'll simply substitute this. So we can simply write this. We can simply not do this. You can simply say you put your bracket or parentheses. This is F centrifugal force minus Fs like this inside the brackets, multiply by the radius of the drum, multiply by the number of shoes. This is how you'll calculate the torque. This is how you calculate the torque, right, during centrifugal, under centrifugal clashes. So the torque we know, isn't it? So yeah, if you want to take advantage, since you want the mass, for you to make this equation simple, let's make this the subject of the formula, guys. So if we make that the subject, we'll have torque. Divide the torque by coefficient of friction, divide it by that. We have coefficient of friction multiplied by R divided by N like this. This will be equal to Fs minus Fs. All right. Good. All right, good, isn't it? So we know the torque, we know. We've just calculated it now there, right? Is 371,361 over coefficient of friction. It was 0,35 multiply R, which is 0,136. No, not 136. No. Remember, 136 is the radius of graduation of gravity. Then R is this. Do not make mistake. This is the difference thing. This let us make no mistake. This would be 0,165 meter like this. All right. This will be 0,165 multiplied by the contact. The number of shoes is 4. This Fs, we've just calculated this in terms of M and this in terms of M. Okay, here it is. Here is the guy in terms of M and Fs in terms of M. So of the mass 199,157. As you can see, we have 1199,157 mass. This is mass, not meat, mass. Let me do this. M represent mass, right? This is the mass minus also Fs, the friction, the spring force. Here it is. This 587,587. That's okay. 587,587. The mass. All right. So check here. Here we still have this. What we have? 137. Oh, sorry. 371,361, 0,35 times 0,165 times 4. We have the common fact. We can keep the common fact. We have something which is common there. Or we can simply just minus. It's one and the same thing, guys. It's one and the same thing. You can punch this on the calculator. It's one and the same thing, but okay, you can take out the common factor. If I take out the common factor of M, I'll be left with 199,157 minus 587,587 like this. Then you know the maths. Divide all this by this 199,157,587,587 all the throughout, right? You can punch this side, then that only that will be 1607,623. Then you divide by this. Remember all side. Divide by 1199,157,587,587. This will be equals to what? This mass now. Now to find the mass, just simply punch this on our calculator. Therefore, we're supposed to get our mass to be nicely to be equals to 3,629 kg kilograms. So this is how cookie crumbles. So guys, thank you for watching. Thank you for watching. Thank you for watching. And please join us by subscribing, by being the part of the family, by subscribing, and feel free to comment and to like and to share this to your fellow classmates. Thank you guys. All the best.